So let's look at the parameterized classes. So far, what we have looked at, we looked at basically the classes, like for example, the random class that was in the java.utl package. But right now in here, you can see that something shows array list E, which is a little bit different. So array list, as we said, is a collection, is a class name, is followed by some information that is in the angle bracket. Classes that look like this are called parameter classes, or sometimes we call it generic classes. The information in the bracket will tell us when we use these classes. We must supply one or more type names in angle bracket to complete the definition. So we have already seen this in the chapter 4 that we have talked about this array list. So it could be a parameter inside a variable. So basically, if we look at here, E is a parameter and the get is a method, and that's the index. So when we have the Boolean in here, the answer could be true or false. So we have the add, which is a method, and then we have a parameter inside a variable E. So if we look at here, so we have used this before. The ticket machine is the parameter of this, and we are using this ticket machine. We are using the get method to assign the index, and then we have the Boolean, which could be the answer could be true and false, and we could either add the ticket machine to this variable E, basically. So we are adding the parameter into the variable E. So some small review here. As we said, Java has extensive class library, which we saw. A good programmer should be familiar with the library and be able to use the classes as per needed. Basically, the documentation tells us what we need to know to use a class and its interfaces. And we just learned that some classes can be parameterized with additional types. And parameterized class, as I've just mentioned, another word for it could be generic class or generic types. So let's look at more sophisticated behavior using library classes to implement some advanced functionality. So some of the main concepts that we are going to talk about is going to be further library classes, set, map, and also writing documentation, the Java doc. I will not cover using set and map. I will just let it for you to read. It's on page 219 through 223. So if you have any question, just let me know about these two. I'm going to go and talk more about documentation and also look at the second project and third project to see how we can actually make our system more intelligent for the support systems. So we're just going to jump to slide 30, which is writing class documentation. So basically, your own classes should be documented the same way the library classes are. Same way that how they have been written, we can basically document the same way. So one thing that we want to make sure that other people be able to use our class without reading the implementation part of it. So make your class a potential library class for later on so that the other people can use it. So some of the elements of documentation for class should include the class name, a comment describing the overall purpose, the characteristic of class. It has to have the version number because always we are trying to improve our classes, and so we always, any type of improvement, we try to keep different versions of it. And also you should have author's name because sometimes you might work 2-3 people at the same time on that class, so it's always beneficial to have different author's name in there, and documentation for each constructor and each method should be documented as well. The documentation for the constructor and method should also have the name of the method, the return type, the parameter name, the type of it, the description and purpose of that method, and also the description of a parameter if you're using, and the value that would be returned by that parameter. So it's always important to look at the source code, so some things that we are talking about in here, in the class you can put comments. So I was just showing you basically how we can, if we look at this, you can see that that's how they are making the comments. They have the author, they have the version, all of that. So you want to use this documentation, and for every class that they create, so they have this. So what they are doing, so basically this is creating a technical support system. So you can put all of these comments inside your program. So what does it do is start the technical support system. This will print a welcome message and enter into a dialog box. So it's basically explaining what this is doing. Also for method, you have your comment. So as you saw in there, for our method, we also have our comment. What does that method do? So basically, this is printing the welcome message on the screen. So for your method, you will also have the comments in there. So basically, we are going to talk about public versus private. So public elements can be accessible to objects of other classes. So field, constructor, and method, they can all either be public or private. So far, mostly we have seen that the fields are private, and public constructor and methods and constructor are public. So field should not be public because it is kind of your own work, and basically you decide what kind of a field you want to have. Private elements are basically only accessible only to the object of the same class, and only methods that are intended for other classes should be public as well. So basically the methods can change the parameter of the fields. Fields are basically statics, so method can help us change the parameter of the fields. Now let's look at information hiding. Basically, data belonging to one object is hidden from the other object. Basically, sometimes if a programmer make use of a class, should not need to know the internal details of it. And also a user should not be able to know the internal. The meaning of not need to know, we talked about it, means, and we talked about in chapter 3 about abstraction and modularization. We talked about it, maybe, if you don't really need to know the whole detail of it. So if, for example, if you wanted to know every single detail of internal of every class, we would never be implementing the large systems. We just have to know how to use them. So basically the main thing is that the programmer should need to know what an object can do, not how it does it. You might not need to know all of those information. Information hiding increases the level of independence, and independence of the module is important for large system and maintenance as well. So they are not going to be dependent on each other. So if one part is not working, the other part is going to be working. So basically, this ensures that one class doesn't depend on exactly how another class is being implemented. So as we said, this is very important for the maintenance work. For code completion, in BlueJ editor supports lookup methods. We can use the control space after a method call dot to bring up a list of available methods that are out there. And we can also use the return to select the highlighted method. So you can use this to be able to see the highlighted methods that are out there. Let's look at another review. Java has basically an extensive class library, as we said. A good programmer must be familiar with all the libraries. A documentation can tell us what we need to know to use a class or the interface. As we said, the implementation is hidden. Some information could be hidden. We document our classes so that the interface can be read on its own. We put in the class, we put the comments. For the method, we put the comments as we showed you before. So the last thing that we are going to look in this chapter, we're going to actually look at class and constant variables. Now let's look at class variables. Class variables is shared between all instances of classes. In fact, it belongs to the class and exists independent of any instances. The keyword static in Java syntax is used to define the class variables. Basically, class variables are those fields that are stored in a class itself, not in an object. Public static variables are accessed via the class name. For example, thermometer.boiling-point. So they can be accessed via the class name. Basically, in the project for chapter 6, you can see this basically the bouncing ball project. And in the bouncing ball project, you will actually see this instance variable and a class variable. So these are the instance variable of this class, bouncing ball. Ball 1, ball 2, ball 3 are the instance variable of the bouncing ball class. Another thing that we use frequently for the static keyword is define constant. Constants, they are very similar to variable, but they can change their value during the execution of an application. So their value is fixed. So, for example, we have the size of the integer, so designated by the final keyword here, and then we have the size of it. It could be like maybe 10, 20, and so on. So final fields must be set in the declaration or the constructor, and combining a static and the final is very common to do. So if our value is intended not to change, we declare it with final. That makes sure that it cannot accidentally be changed later on. So any attempt to change a constant field will result in a compile error message that you might see. So constants, by conventions, they are written in the capital letters. So we follow that convention in this book. So, for example, if we have private static final integer size equals 10, if the size is in cap, that's the constant. And we are giving the value of 10 to that size, which is a constant. So if we use a static, it's a class variable. And if we use final, it's basically constant. So sometimes you can use the final and a static keyword in combination of together, which in here you have private static final and integer gravity equals to 3. So the gravity from our bouncing ball project is another example of a constant that we have here. And in this style, in which constants are defined most of the time, we have instant and specific constants are much less frequently used. So, and also we talked about uppercase names often used for class constant as well. So in here, the boiling point, if it's uppercase, is basically constant.